Okay, class, let's move on to number 5. By doing exercise 4, you found out how the position of the line that is the graph of y is equal to ax plus b changes as b changes. So we saw how that, particularly with the y intercept, or that y point, as b changed, so did that. By doing this exercise, you will see the effect of changing a. So we're going to make a table for each of the following linear functions and let x equal to 0, 1, 2, and 3 in each table. So similar to what we did before, just going to have a different set of equations or functions. And let's see, y is equal to 2x plus 1. Then we have y is equal to 3x plus 1. And the last one is y is equal to 4x plus 1. Okay. So again, let's create our tables. We have x and y, x and y. You might notice I'm using a thicker pencil now. I noticed that in the videos it wasn't coming out as clear. So, all right, so we have x and y values. Let's go ahead and put x as 1, 0, 1, 2, and 3. So that'll be the same for all. You can see I'm just kind of rushing along. I know these are going to be the values, so I might just write them all in. Now, let's put in the x value in the first equation, and we get 2 times 0 is equal to 0 plus 1. So that'll be equal to 1. 2 times 1 is 2, plus 1 is equal to 3. 2 times 2 is 4, plus 1 is equal to 5. And 3 times 2 is 6, plus 1 is equal to 7. Okay, now let's do our next one. 3 times 0 plus 1 is equal to 1. 1 times 3 is 3, plus 1 is equal to 4. So we have 2 times 3 is 6, plus 1 is 7, and 3 times 3 is 9, plus 1 is equal to 10. Okay, now let's do our last one and take a look at all this. 0 times 4, that's 0, plus 1. So again, 0, 1. 1 times 4 is 4, plus 1 is 5. 2 times 4 is 8, plus 1 is 9. And 3 times 4 plus 1 is 13. Okay, so if we look here, we can see that our first point is always the same, 0, 1, 0, 1, and 0, 1. But we do see some changes going on here, so we're going to have to see how that affects our graph. So why don't we go ahead and follow the instructions now and graph the 3 functions on one pair of axes. This is an axis, the x and y axis. We're going to do it on one because we want to compare. All right, very important to follow those instructions. And then we're going to write the equation along each line. Okay, in this particular case. In fact, I think we didn't do that in the last one. I skipped that. You should never skip each step. It's just a way of labeling the line so you can see it. But let's go ahead and do it in this one. So let's, I'm going to need to get my black marker. Now in this case, we're going to change the scale a little. I generally don't like to have that scale change too much, but in this case, I do need to get some of these in here. So let's go with 2, 4, 6, 8, 10, 12. And when I say changing the scale, I could easily go 2, 4, 6, 8, 10. But the only problem with that is that I'm going to really squeeze everything into 1, 2, 3. So it's okay to do this when you're limited for space. But I really don't recommend it. If you really need to see like the slope of things, when you're analyzing things, you don't want to flatten things out and distort. In this particular case, we're not really interested so much in the way the slope is behaving. So let's just go ahead. And again, everything is comparative to the other elements that are here. So we're using 3, so we're just going to be comparing them all within that same context of slope. Oop, I don't think that's part of our problem. So let's remove that. Now we're going to go ahead and start plotting our points. Okay, and our points start for the first one at 0, 1. So 0, 1 would be approximately right there between the 0 and the 2. That would be a 1. So 0, 1. Then we go 1, to 3. Okay. Then we go 2 to 5. And our last one is 3 to 7. Okay. And now, let's go to our next one. Our next line is going to start at 0, 1. Interesting. In fact, let me just go ahead and draw that because this is going to get a little bit busier. So we're going to just draw this one out and just connect these and say this is our graph. Okay. So go back and get my pencil and we're going to do the next one. So it starts at 0, 1 again. So we have the same starting point, but the next point is 1, 4. So that did change. And then it goes to 2, 7. Okay, so that would be there. And then 3 would be 10. Okay, so that would be right there. Oh, excuse me. Yeah, 2, 7, 3 to 10. All right. So now we see that this angle is slightly different. We go 0, 1, 1, 4, 3, excuse me, 2, 7, and then 3, 10. So we're going to connect that one as well. And when we do, we'll see our line is shooting straight out. Points are well placed. And now we'll go to our last one. And our last one is going to be starting again at 0, 1. And now we're at 1, 5. Okay, so now we're here. Then our next point is 2, 9, which will be way up here. And our last point is 3 and 13, which is all the way here. So let's connect these and compare our graphs. And now what we don't have is, as we had in the previous one, we do not have parallel lines, but we do see that they all start right here at 0, 1. Okay, so while we can see that in our equations we have 2x, 3x, 4x, that is changing the slope, okay? But the plus 1 did not change, which meant that our y-axis was always going to be there. And if you really look at it, no, it doesn't matter what the a constant is. In this case, it's a 2 or a 3 or a 4. When you multiply by 0, it will always equal to 0. So the y will always equal to 1 regardless when that is when the x is at 0. Remember, when x is at 0, we're actually on the y-axis. So it gets a little tricky understanding how x relates to y, but with practice and exposure, you'll feel more comfortable with it. So now we're told to write. Let's do it this time. We didn't do it last time. And we're just going to go and write. And how would you do that? Well, I would write here y is equal to 2x plus 1. Over here I would write y is equal to 3x plus 1. And then lastly, y is equal to 4x plus 1. All right, so we should have done that with the last one. And we didn't. But that's what it would look like. So we've labeled them. We notice that they intersect right there at the 0, 1 point. Okay, and where do you think the graph of the equation y is equal to 10x plus 1 would meet the y-axis? Well, if we just write it right there next to, let's write it in white, we can see it's in that same form of ax plus b. It would be 10x plus 1. Well, this one intersects at 1, this one intersects at 1, or at 0, 1, let's say. This one intersects at 0, 1, so it'd be safe to say that this one also intersects right here. Because when we put in 0 for the x value, we would get y is equal to 1. And 0 for the x value means we're not moving off, we're not moving across, we're staying on the y-axis. So we're just going to move up, and in this case, we'll move up to 1. So that would answer G. Let's go on to our next video.